So as we review for 7.1 and 7.2, as I mentioned here, we're talking about absolute values, just an introduction to absolute values, numbers and operations with absolute values. Then we moved into, well, I'll do a word problem with absolute value sort of operations. 7.2 talks about graphs of absolute values and how to graph absolute value functions, how to graph the piecewise functions that make up the absolute value functions, and things like that. So we're going to work on 4 or 5 questions here in review for 7.1 and 7.2. So number 6 in 7.1 is a question that you may have done. If you haven't, for sure I'd like you to do this with me. You can copy out the question. Let's do A, and then let's do D maybe. So just to make sure we're all on the same page, you're going to do a question like this on your quiz. So 6A says that we have 2 as a scalar, as a multiplier out front, and then here's where the absolute value signs are. So everything inside, you can treat these absolute value signs like brackets, and so we're going to do that. The operation inside the brackets, that's going to be negative 6 minus a negative 11, or negative 6 plus 11. Now it's important to note that you do not just change all the negatives. Like, you don't just make all this positive. Okay? You don't do that. You have to do the operations just like they're brackets, and then when you apply, and that's what I call it, apply the absolute value signs, then you change whatever that clump is to a positive, or just get rid of the negative. Okay? Then you just change it to a positive version. So that's what we're going to do. We're going to evaluate inside here first. So that is negative 6 plus 11 is positive 5. If we apply the absolute value signs, that's 2 times a regular old 5, which looks like it should be 10. Okay? Good with that? And in the process here, if you notice me making any mistakes, please ask about it. All right, D. So if we look at D, and maybe I'll just rewrite D here. So we've got absolute value signs and brackets. Okay. The absolute value signs are definitely on the outside of this expression, on the very outer edges there. So we're going to do everything inside, treating them like they're just regular old brackets. We'll just evaluate that first. So we'll keep that absolute value sign there. Do I do multiplication or the exponent first? Yeah, always exponent first. BEDMAS, right? That's great. So let's do 3. Negative 2 squared is positive 4. Please be careful not to say a negative 4. It's a negative times a negative. This is plus negative 10 plus 7. Okay? So this is going to be 12 minus 10 plus 7. 12 minus 10 is 2 plus 7 is, looks like positive 9. And when you apply the absolute value signs, of course, it's just a regular old 9. All right? So any questions about that? Both these ones I chose happen to be positive numbers before we applied the signs anyways, I guess, but you get the picture. Okay? Can you all do that? Are there any questions about this? I can take questions on any of these right now. I just want to make sure that you're all able and comfortable to do this. Good? All right. Next question is the word problem number 7. Number 11. If you have something like this, we have to understand what this is asking, and then use absolute value expressions here. So for number 11, when Vanessa checks her bank account online, it shows the following balances. October 4th, she has $359.22. On the 12th, it's $310.45. So it's dropped a little bit there. On the 17th, it's dropped again. On the 30th, the end of the month, she's gotten paid for work, whatever. So it goes up, and then November 5th, she's made some withdrawals again, and it goes down again. So the bank account itself is sort of going down, it's jumping up quite a ways, and then it's going down a bit. So this is sort of what's happening to the bank account. The question says, use an absolute value expression to determine the total change in Vanessa's bank account. So this is very important. The total change in Vanessa's bank account balance. That is referring to an absolute value of just recording all of the changes. It's not a difference between the beginning and the end. Okay? We're counting this change, then we're counting this change, then we're counting this change, and then we're counting this change. And we're taking really the absolute value of all those changes. The positive or negative doesn't matter. Okay? So that's the important part of this here. So, doesn't matter, because it's absolute value, doesn't matter which one you take. First, you want to find the difference between these two. So usually you take the second minus the first, right, to find the change. So this is going to be 310.45 minus 359.22. But that's going to be an absolute value. So you would add to that the absolute value of the next change. And that's going to be 295.78 minus 310.45. And again, because it's absolute value, doesn't matter which one you subtract, because we're going to be adding the absolute value anyways. So we keep going through all this here, and just looking for the differences. And finally, okay, all of the absolute values of these, and you add all those up. Okay, when you add all those up, you should get, let's see, you should get a change of, so it should be 369, 30, I think I said 37. Yep.
You wrote it wrong. The first time you rate 425.59, it should be 295.6.
Okay, good catch here. This should be the 295. Not sure if I said that wrong or just wrote it wrong. But yeah, so 513 minus the 295 right there. And I think that answer is still the same. So the difference between those two, the difference between those two, the difference between those two, difference between those two. You take the absolute value of all those and you add that up, you should get this. So the bank account changed a total of $369, and that's different from B. How is that different from the net change? Again, from the beginning of this question, as I mentioned, the net change is just the difference between the beginning and the end. So the net change would be your final balance minus your original balance, right? And when you calculate this, that's the total change. And then the positive and negative actually does mean something, right? So 425.59 minus 359.22. 6637. That look right? So that's the total change. So not much from beginning to end, but all the changes combined. All right. Okay, good. Any questions about that? Okay, let's move to 7.2 then. Let's talk about a couple of these questions right here. So in 7.2, this is one of these is number 5, and I think one of these is number maybe 7. Yeah, this is 5A and 7B. All right. So you need to know how to do this. If you're given a graph and you're asked to graph the absolute value, pretty simple. All of the positive y values, those do not have to change. But any parts of the graph that have negative y values, those need to change to positive, right? So if this y value is 2, the absolute value of 2 is 2, so it stays the same. If this y value down here is negative 1, the absolute value of that is positive 1, so it has to go up here. So if we're going to graph the absolute value function in red, you go down till it hits the x-axis, and then every point from then on is reflected. So it's the red one, looks like this. The absolute value is the red graph there. Okay? The same holds true for something like this. Remember, anything that has a negative y value, because we're trying to graph y equals the absolute value of f of x, so anything that has a negative value has to flip to a positive value. So these points down here, this arm kind of down here, looks like this. So all of these, oh, that's actually, I've curved that the wrong way, sorry. Like that. Okay, so all of those are reflected. These are reflected up there. And it looks kind of like, okay. And then the middle, the positive part, is the same. So the graph that is the absolute value function is the red graph here, like that. Does everybody get that? From the graph shouldn't be that big of a deal. Just fold everything up. Everything that's underneath, fold it up. Just kind of take it, fold it right on the x-axis like a paper and just fold it up and then sketch the new graph. Okay. All right, number 8. Number 8. Now this just gives you an equation and asks you to sketch it. So okay, let's take a look at some of the features here. Obviously, wherever the y is negative, it has to switch to positive. So we should find out some important characteristics of this. This looks like it's going to be a parabola, right? Because it's a x squared here. That's a parabola. So you can do a few different things. You can actually graph this the positive version of this, like just the regular parabola. You can graph that and then flip it up like we have been doing. Or you can do a couple things like this. Let's figure out what the y-intercept is, what the x-intercept or intercepts are, and then we'll kind of go from there and find out how we can sort of piece this together. So this is a good place to start if we're not graphing it first. Okay, so the y-intercept would be where x is 0, right? So this is going to be 0 minus 4, the absolute value of that, or the absolute value of negative 4. So y is going to be positive 4. Now you can see that on the regular graph, it would be a negative 4. So let's kind of draw the coordinate plane down here. So it's actually going to be y equals positive 4, which is going to be a reflection of what the regular graph would have been. So the other graph would have been down here somewhere, looks like, right? The vertex. So this is going to be up here, like this. So that's the y-intercept. The x-intercepts are where y equals 0. So, okay. And we can do absolute value. 0, there's no absolute value for 0, really, so it doesn't really matter if we have the absolute value signs there. So this is going to be x plus 2 times x minus 2 when you factor this. And so your x's are going to be negative 2 and positive 2. So that's where your intercepts are going to be, there and there. Okay? So now you can kind of piece these things together. This looks like, because that's a positive x squared there, that's going to be a parabola that opens upward. So you can plug in some more points if you want, and I would suggest that. So if you had a little, let's change colors over here. So if you had some x, y, you could plug in some points, because how do you know exactly what this looks like? Well, everything should be above the x-axis. But what about this x equals 1? If x equals 1, what happens to this function? Well, you could just do that real quick and find that out. 1 minus 4 is negative 3. Absolute value of negative 3 is positive 3. So it's going to look like this. So you can kind of see that, hey, these points are kind of coming down here. So here's your graph. It's going to look like this. It's going to be symmetrical, right? Negative 1 would also be, right? Negative 1 would also be 3 there. And then you could try a point 3. 3 squared is 9 minus 4 is 5. So 3 is going to be up here at 5. So you just start putting your points together, and it looks like you have a graph that looks just like this. And that would make sense because the positive version, or the non-absolute value version, would have its y-intercept down here, right? And so on. So that looks reasonable. So that's how you might graph that. The domain, okay, so the domain, remember there are no restrictions for x here. Okay, if you just look at x squared minus 4, there's no restrictions on x. So that's x can be anything. But the range, okay, the range has to be greater than or equal to 0. We can see that. So y is greater than or equal to 0. And that's acceptable for that. There's your x-intercepts, there's your y-intercept. Okay, so for a question like 8, that's what you need to do for 8. So any questions on that? Look at number 9 on 7.2. This is 7.2, number 9. And it says write the piecewise function that represents each graph. Okay. So remember, when we have an absolute value, there's going to be some function that's going to represent part of the domain and another function that's going to represent another part of the domain. One of these will be positive and one of these will be the negative version. Okay, so you can think about that. One of these is the negative, one of these is the positive. And then this x value right here is going to be the x-intercept or x-intercepts. But in this case, we need to find out what this x is because that's kind of the cutoff point, right? Going this way from there, it's the positive, y equals positive, right? On this side, it's the y is the negative version because it's going down. The slope is going down. So you got to think about that. So this is one line that we need to find the equation for right here. And then this is the other line, the negative one, that we need to find the equation for. All right. So they give you actually the equation here. That's pretty nice of them to give you the equation here. So we would have the regular positive version of this, 2x minus 2, where x is greater than, what's this x-intercept? It appears to be number positive 1. Well, let's just check. Okay, what is the x value when y is 0? Well, that's 2x equals 2, x equals 2 over 2, or 1. So what that means is from x equals 1 and greater, that's where it's this absolute function looks like the positive version. So when x is greater than or equal to 1. All right, so you're splitting that in half at the x-intercept. And then over here, it's basically the negative value of this function. So you have to be careful to distribute this negative sign. And actually, to be honest with you, I guess right now I'm okay with you guys even just writing it like this, the negative version of it. I'm okay with that. So that's the negative version of this line. And that is when x is less than 1. Where x is less than 1. All right, any questions? So yeah, so you might, like I say, you might find that this, that they might rewrite that like this, okay? So that may be rewritten like this, which is just with that negative sign distributed. Either or is fine. Okay, so finally one more. Let's do the same thing except without, we're not given a graph. So we kind of have to find some of these pieces by ourselves. So let's take a look at 11a here and express each function as a piecewise function. So one of the things you might want to do first is to find out what the x-intercept is, right? So let's let y equals 0. So that's 0 equals x minus 4. And again, 0 is neither positive nor negative, so it doesn't really matter if you have the absolute values there. It doesn't really matter. So at x equals 4 is where we're going to have our x-intercept. So in our piecewise function, you're going to have some equation here, some equation here, and one is going to be beyond 4, one is going to be less than 4, right? Because that's our intercept. Now let's think about it. Y equals positive x minus 4, and y equals negative x minus 4, or negative x plus 4. From what you know of this is a line, so we're going to have some kind of v, right? Some kind of like this. So if x equals, so this equation right here, the first one, that's going to be this, right? That's going to be this line right here. So this is our x-intercept. So it's going to be this equation, x minus 4, when x is what? Well, we said that the x-intercept is 4, so when x is greater than or equal to 4. Okay, we good with that? And then the negative version, well, negative x with an intercept of plus 4 looks like this. So we need to identify this part of that. So it's going to be negative x plus 4 when x is less than 4. Okay. And that's how you express that as a piecewise. Right here. Questions on that? You guys good? Now, if you do a one like this, okay, again, what you want to strongly consider is what is this without the absolute value signs, right? What is that without the absolute value signs? So a negative x squared plus 1, if you're going to take a look at that one, let me just erase some of this. You might want to think ahead and say, okay, that's a parabola that is opening downward, right? You can envision the graph in your mind, that's no problem. So it's a parabola that opens downward, and it has a plus 1 as a y-intercept. So it's going to be kind of looking like this, right? Okay, so find your x-intercepts, which will be somewhere here and here, right? And then you can picture this in your mind that in between those, you're going to have this x, negative x squared plus 1. And then beyond those, here and here, you're going to have the negative version of this. Okay? So however you piece that together, pardon the pun, for the piecewise functions, however you put that together in your mind, you just got to get intercepts would be helpful, right? And then kind of knowing what this graph without the absolute value might look like, and then thinking about how that changes with the absolute value. So I like to think of the graph when I do this. You may just kind of do x-intercepts, you know, like and your y-intercept like we did in that other question, and then just go from there. All right? One other thing I'll say, how do you express, so this is going to be negative 1 and positive 1, I guess, right? So how do you express a domain between negative 1 and positive 1? Anybody remember that? So this is going to be negative x squared plus 1 from negative 1 to 1. Anybody remember how you do that? No? Okay. Nobody remembers? Okay. Maybe you guys haven't got to this question yet. There should be an example you can find. Yeah, example on page 374 shows it. So you do this, right? You do the x values are between negative 1 and positive 1. So you write it like this. Negative 1 less than or equal to x, less than or equal to 1. These are the boundaries right here, negative 1 and 1 on either side. So this reads x is greater than negative 1 as well as being less than positive 1. That's how you show that. Okay, and then you're going to have the negative version of this. So it's going to be positive x squared minus 1. And you got to show two spots. That is less than negative 1. So x is less than negative 1. And you can use a comma there, whatever. And then also where x is greater than positive 1. Okay? So this 11C is a bit trickier. It's a bit trickier. But again, I don't know if I assigned 11 for you originally, but you should know how to do that for sure. So. Okay, I think that's the last one I had planned for this review. Okay, so that's 7.1, 7.2 review. If you have questions, please ask. You have the rest of this class to finish your 7.1, 7.2, prepare for your quiz tomorrow. Also, if you've done all that, please look ahead to 7.3. That's what we're going to be working on next.